everyone, welcome back to my channel SJR Comtech. Today's my topic is how to perform the subtraction on binary numbers by using the 2's complement. So for this we must know how to perform the addition as well as how to perform the 2's complement also. Why we should know addition rules, that you will come to know at the end of this video. So please do watch video till the end, and as well as I am going to add the binary arithmetic operation playlist at the end as a end screen. So now let me start with the first example. Why first example? Because I am going to explain it with the help of two examples, because you know there are two chances of the subtraction result. That result can be either positive or it can be negative depending on which number is smaller and which number is greater. So please do watch video till the end, and now let me start with the first example. Suppose the given example is 12 minus 5. These numbers are given in their decimal form. So first I have to convert these numbers into their equivalent binary. So how to convert into their equivalent binary? Write the weighted values 1, 2, 4, 8. Now to get the 12, I have to choose weighted values in such a way that their addition will be 12. So 8 plus 4, 12. So write 1 and 1 for 8 and 4. These two are not selected. So write 0. So the binary equivalent for the 12 is 1100. So write here 1100 minus, what is next number? 5. 4 plus 1, 5. So for 4 and 1, I will write the 1. For remaining weighted values, I have to write 0. So 0, 1, 0, 1. This is the binary equivalent for the 5. So write 0, 1, 0, 1. Okay. So if directly binary numbers are given, then directly we will start with the process of subtraction. If the numbers are given in any other number system, then we have to convert those into binary first. Now start with the step 1. In step 1, what we have to do? We have to take the 2's complement of the negative number. So obviously the given two numbers, one is positive, one is negative. So in step 1, I have to take the 2's complement of negative number, which is negative number 0, 1, 0, 1. So here I will write 0, 1, 0, 1. Take its 2's complement. How to take the 2's complement? See the bits from the right side and write those bits as it is in answer until we don't get the first one. Now have a look at the first bit in this number. This bit is 1. So the first bit itself 1. So write this bit as it is here. Now what are the left bits in given binary? 0, 1, 0. So we have to take 1's complement of left part of the number. This number is 0, 1, 0. So its 1's complement is 1, 0, 1. How to get the 1's complement? Simply by replacing 0 by 1 and 1 by 0. Now step 2. In step 2, I have to take the addition of two numbers. Addition of two numbers. Which two numbers? First is 2's complement from the step 1. Okay. 2's complement from step 1. And next one is positive number. So positive number. So what is positive number here? 1, 1, 0, 0. What is 2's complement from the step 1? That is 1, 0, 1, 1. So write here 1, 0, 1, 1. Now take the addition. 0 plus 1, 1. 0 plus 1, sum is 1. 1 plus 0, again sum is 1. 1 plus 1, sum is 0, but carry is 1. Now you can see here we are getting the carry as 1. But sometimes we may get the carry as 0 also. So this carry bit is used to represent whether a result of subtraction is positive or negative. So as this carry is 1, carry is equal to 1. So result is positive. Here we are getting the carry as 1, so our result is positive. So 0, triple, 1. This is the result of subtraction. Now this is in binary form, so we will convert this into decimal to cross check our answer. So write the weighted values 1, 2, 4, 8. So 0 is there, so 8 is not selected. Then what is selected? 4, 2 and 1. So 4, 2 plus 6. Then 6 plus 1, 7. So its decimal equivalent is 7. And as the carry is 1, the result is positive. Now when we use the ones complement, by using ones complement, when we get the carry as 1, we are adding that carry to the result. But see, here we are using the 2's complement for the subtraction. So whenever we are getting the carry as 1, we have to discard that carry, and this remaining part is nothing but the final result of the subtraction. Now see, 12 minus 5, what is the result? 7. Are we getting the same result here also? Yes, this is how you can verify your answer. Now let me take the second example where we will get the result of subtraction as negative number. I will take both the numbers as same. Only here 12 minus 5 is there. I will now consider 5 minus 12. 5 in decimal form, then 12 also in decimal. So write their equivalent binary. Now here I will write the binary equivalent directly. 0, 1, 0, 1 minus 1, 1, 0, 0. Again all the steps are same. Step 1. What is step 1? Take 2's complement of negative number. What is 2's negative number here? 12. Its equivalent binary 1, 1, 0, 0. So 1, 1, 0, 0. It's 2's complement. How to find out? See the first bit, it is 0. So write that bit as it is. See the second bit, again it is also 0. So write the second bit also as it is. See the third bit, yes, now it is 1. So we have to move towards the left side until we don't get the first bit as 1. Now whatever bits are left in the number, we have to take their ones complement. So 1 is there, so replace 1 by 0. So this is the 2's complement of the given negative number. Now step 2. What we have to do in this step 2? Positive number plus 2's complement from this step 1. So what is positive number here? 5. So write here 0, 1, 0, 1. And what is 2's complement from this step 1? 0, 1, 0, 0. Take their addition. 1 plus 0, 0. 0 plus 0, 0. Sorry. 1 plus 0, 1. 0 plus 0, 0. 1 plus 1. Sum is 0 and carry is 1. 1 plus 0 plus 0, 1. What about last carry? Are we getting any carry here? No. That means we can represent this carry as 0. So, if carry is equal to 0, result is negative. So, how to find out whether the result is positive or negative? If the carry is 1, then the result is positive. If the carry is 0, then our result is negative. Now, as this result is negative, this is not, or this answer is not in its true form. So, this is present in its 2's complement form. So, to get the true form of this number, again we have to take its 2's complement. So, here I will write 2's complement. How to take the 2's complement? See the bits from the right side. The rightmost bit is 1. So, we get the bit as 1, first 1 in the given number. So, now what we have to do? Take the 1's complement of the left part. The left part is 1 0 0. So its 1's complement is 0 1 1. This is the final binary number, and this is the result of the subtraction. Okay, so to cross check or to verify our answer, convert this number into its decimal equivalent. Write the weighted values again. 1 2 4 8. What is selected? 4 is selected, 2 is selected, 1 is also selected. So 4 plus 2 plus 1, 7. Okay, this is the decimal equivalent. What about symbol? Whether it is positive or negative. As the carry is 0, the result is negative. So here we have seen in the first example, we are getting the subtraction result as positive. In second, we are getting the subtraction result as negative. How to find out whether it is positive or negative? Just looking at the carry. If carry is 1, result is positive. If carry is 0, then our result is negative. Now, here you might have observed that at last actually we are getting the result of subtraction. Yes, but here have you performed any subtraction operation? No. Just here we have used the addition operation. Okay. So actually we are getting the result of the subtraction, but internally we are performing the addition, and this is the magic of using the 1's complement and 2's complement for the subtraction. Then why to use the 1's and 2's complement? Suppose one hardware is designed for performing the addition of binary numbers. And now by using 1's and 2's complement, you can perform the addition and finally you can get the result of the subtraction. Then why to design one more hardware to perform the subtraction? So this is the magic of 1's and 2's complement to use the for the subtraction on binary numbers. So this is a very simple method to perform 1's complement as well as 2's complement for subtraction. So if you understand this video, please like the video. Yet if you are not subscribed my channel, don't forget to subscribe as well as click on the bell icon also. And don't forget to share these videos with your friends. Thank you.